The first result that we can see is the build part printing process along the z-axis. You can see that in time the layers are printed one after the other. Let's see the printing again, and this time I'm going to use the movie player controls buttons. Also, I want to compare the printing process with the material event series data. Now let's see what happened in the next images. See, half of the first layer is created in the time of 0.2 seconds. The other half is created in the time of 0.35 seconds. In the material event series, we determined that the material of the first layer will be added from 0 to 0.5 seconds. But it seems the results and data are not matched. And why is that? Well, as we said before, the speed of the roller is specified with the data we entered. What happened between these points depends on the software. The software gets these data and interpolates between them to add the material. Why half of the layer? If we mesh the build part with a smaller size to have more meshes, you will see that in the time of 0.2 seconds fewer meshes and the smaller portions of the layer will be printed. Let's use the events and see the roller's movement when adding the first coat of powder. As you see, when the time equals 0.1 seconds, the roller is here. After the 0.05 seconds pass, it's here. And in the time of 0.2 seconds, half of the first layer is added. Now see the rest of the event. The same thing will happen for other coats of material. Enough about the material, let's see the thermal analysis. First, let's talk about temperature changes. At the beginning of the analysis, there is only the build table, which has an initial temperature of 80 degrees Celsius, as we expected. The temperature remains almost intact till the first coat of powder is added. In 0.4 seconds, the first coat of powder is added completely, and it's ready to be scanned. This is a heat transfer analysis, so the temperature is a little bit decreased because of the first layer. Also, you can see that there is heat flux because of the initial temperature we had. There is no sign of the laser yet, because the laser starts to scan the model in 0.4 seconds. From now on, we must expect a huge temperature and heat flux increase because of the laser scan. From 0.4 seconds to 0.66 seconds, the laser scans the layer. Let's see what will happen to heat flux and temperature. Meanwhile, let's use the events to see the path the laser passes through. First, heat flux. Did you see the huge jump in the heat flux? Let's do it again, and this time pay attention to the legend. The laser is here and the heat flux value becomes 1000 times bigger. Now let's see the temperature. The temperature will be increased and changed during the scanning. As you see, we have the maximum temperature near the laser beam. See the temperature changes when I go to the next images. This is the end of the scan of the first layer according to the laser event series data. Now, from 0.66 seconds to 5 seconds, we must expect a decrease in the temperature and heat flux because of the cooling process. Why till 5 seconds? Because after that, the second coat of powder will be added according to the material event series. Let's see the changes in action. First, the temperature. See, the temperature decreases. As you see, when the time is nearing the 5th second, the temperature is reaching to 40 degrees Celsius, which is the initial temperature. There you go. In time 5 seconds, the temperature is 40 degrees Celsius, which is the exact value we specified in the load module. After this, the second coat of powder will be added. Now let's see the heat flux. See, the heat flux decreases as well. This procedure will happen to all layers. After the coat of powder is added, the laser scans the material to form the layer. The temperature and heat flux increase till the scan is finished. After that, the cooling process will be in progress. In the last increment, the heat flux and temperature value are high. And why is that? That's because the input data, the laser event series, and the time period are imported till this far. Let's open up the laser event series again. Look at this data. The laser scan is not complete, as we said before. There is no sign of the cooling process in the last layer. This is just a tutorial video. You should enter your data completely to have an actual analysis. As for the final thing, let's see the temperature changes of a node in a plot during the analysis. So click on the XY data tool. Select the ODB field output and click Continue. Select the unique nodal from this combo box and select the nodal temperature variable. Go to this tab, click Edit Selection and select this node for example. Then click Plot. This node belongs to the 8th layer. When the laser scans it, the temperature increases with a high slope. Then it decreases in the cooling process with a high slope. The slopes are dependent on the thermal properties like conductivity and specific heat defined in the property module. When the next layer is created, the temperature will increase again, but not as much as before. It's because of the heat transfer from the laser scanning of the next layer. Then it decreases again. This happens to all nodes. I think I have covered all things in the heat model.